Hi there, this is Mr. Zand, and today we're going to talk about enthalpy, endothermic reactions, and exothermic reactions. Okay, so just to begin with, let's get going with products and reactants, what the heck those things are. So I'm going to just, I'll just have like a generalized equation right here. So this is going to be reactants, and then they go to products. Products over here. Okay. Right. Now, if these reactants are very, very stable, it's going to take some energy to turn them into products. So let's just assume that these reactants are very, very stable. So very stable. So let's say very stable reactants. When we say very stable, what we really mean is low energy. So low energy. And then if we change these very stable reactants into less stable products, so we rearrange them, so now they're less stable relative to these very stable reactants. They're going to have, we'll just say, relatively high energy compared to those reactants. So if we want to graph this over time, so let's just say this is the reaction progress going this way, and energy on this axis going up. These reactants, which I'll show as red, these reactants right here, these reactants, let's say that they're fairly low. We're not giving any values to them. Notice that these are just relative values. But let's say now you have to put, so these are the reactants. They're at this energy level right here. And then let's say that you put in some energy. And I'll change this to a different color because now we're in product land. Or we're here in products. Okay. So these products, they're up here. So these products have higher energy. These products have higher energy than those reactants. So it required you to put energy into these reactants to lift them up to the level of products. So you've lifted them up in the energy scale over here. So the products, they're less stable than these reactants. Okay? So that means that they could easily come tumbling back down over here. It's kind of like a hill. So they could come back down to the reactants. So the reactants, it requires a lot of energy to put them back over here into the products. These things can go back and forth, but what I'm saying right now is that these products are higher in energy than the reactants. So it requires you to put in energy to the reactants to turn them into the products. Notice it does take some energy to put the products and change them back into reactants because it has to go over this little hurdle right here. Most of the time, that's the case. But overall, the products have higher energy than the reactants. So when you have to put in energy, put in energy to create higher energy products. This whole process right here is an endothermic reaction. All right? So, think about this. If you've got something, you put heat into it, and you create something else. That's an endothermic reaction. Okay? But think about what it feels like to you on the outside. Let's say you're holding this reaction in your hand. If you are holding this reaction in your hand, okay, so let's just assume that this is like, let's say that this reaction is going on in a beaker. Here's a beaker. And here's your hand. It's holding this reaction going on right here. And I'll make it blue. Okay, so the reaction is going on inside this beaker right here. Okay, this reaction right here is going on right there. It's going from reactants to products. It's an endothermic reaction. So where is this reaction getting its heat? Where is it getting its energy? Well, it's getting its heat, it's getting its energy from you and from the surrounding air. So the energy is going in. I should have drawn that in a different color. I'll draw it in red. It's going in. The heat's going in. The heat's going in. The heat's going in. It's getting its heat from its surroundings to create the products, which are less stable. So this kind of reaction feels like something to you. If you're losing your heat, what does it feel like to you? You say, ah, it feels cold. That's the way we kind of express ourselves in our common everyday language. All right? But what's really going on here is that this reaction is taking your heat to create its products. That's an endothermic reaction. That's very different than, you can guess it, an exothermic reaction. So I'm going to draw an exothermic reaction. I'm going to get a whole brand new page right here. Okay, so an exothermic reaction, if you've got the reaction process going, so here it is. So the reaction is going in this direction, and the energy is going up here. Okay, so if your reactants now, so let's go from reactants. Let's do reactants up here, and it goes a little jump right there, and let's say the products are down here. Okay, so up here are the reactants, down below is the products, just in terms of our reaction progress right here. So here the energy is higher in the reactants than the products. So when that happens, so when the energy is higher and it's released and the products have a lower energy, so you can describe it this way, when the reactants are less stable, so in other words, higher energy, than the products, this whole process is something called an exothermic reaction. Heat is exiting the system, exothermic reaction. So if you have this reaction going on again in your hand, or in a beaker on your hand, here's your hand right here. Right, that's a hand, trust me. This thing's going on in your hand, and you feel something going on. What do you feel here? So this thing's going on in here. There's a little beaker. You've got the reactants turning into products. The products are a lower energy, so that means that energy is exiting this system. So this thing, what does it feel like to you? You say, oh my God, it feels, and it's not just exiting there, it's exiting to the air too around it. It feels hot. So to you, if it feels hot, it means that it's giving off energy to the system, or I'm sorry, to the reaction surroundings. So this is an exothermic reaction if it feels hot, endothermic if it feels cool. All right, so that's the difference between exo and endothermic. Another way to describe these are that the reactants are less stable than the products. The products are more stable. That's an exothermic reaction. That's opposite an endothermic reaction where the reactants are more stable than the products, or they are lower energy than the products, which have higher energy. That's an endothermic reaction. Okay, that's the distinction between these. Now we have to talk about enthalpy. So let's talk about enthalpy. Right, so enthalpy. Let's get a new sheet for that.